So at the end of step 3, I mentioned we'd come back now and look through these machine files together and identify what needs changing maybe to make it work on your machine. If you've been cursing me ever since step 2, because every time you do a firmware restart you get this instead of that pretty dashboard, I do apologize. It totally escaped my mind. It's been so long since I first installed Klipper that, of course, Klipper needs to know the serial interface of the printer. When you plug your USB cable in, the Linux operating system creates a device for it, gives it an identity, and then Klipper says, okay, so what's the ID for the printer? What you have in your printer config file right now is the ID of my printer, but that may not be the ID for yours. So if you're looking at a red message like that, again, I apologize. Let's go into printer config, and I'll start with that one. So Control F, MCU, takes you down to what is called a section. All these things in square brackets. Klipper calls these sections of the printer config file, and within there are parameters, variables, that you can define. The one called serial for MCU is an address in a Linux file system on the host. Now, I deliberately corrupted mine so that I could demonstrate this problem. You'll see in printer config, I didn't leave you totally high and dry. I did leave you a note. You just didn't know you had to find that note. So if we Control C to copy that address, and then I cheat and I go here and show you I've already pasted that address here, and this is where you'll go. Where is my serial port? Read carefully. The general way to find a USB serial port is to run this command. So you can read the rest at your leisure, but let's copy that command and now go to PuTTY, which I have conveniently opened and logged into. You'll need to do that first. When you're at your home directory, right-click to paste what we just copied, that same command, right, and hit return. You'll see your address. Left-click on the right side of that text, drag your cursor over to the left margin to select all of it. When it's all highlighted and nothing else is highlighted, just that, let go of the left button. It'll now copy that text to the clipboard. You don't get any feedback. You just have to know. Come back here now. Take this address away and paste your new address. Take away the extra line. Now the correct address for your machine is in your printer config. Save and restart. Verify that it now logs in. You have your dashboard here, well, what they call dashboards there. You have this screen now. You don't have this error message anymore. Congratulations, you've done the first important thing you need to do to tailor this installation to your printer. Those of you with a Macs will need to look through all of these files, identify things like this, for instance, where the home XY position is the center of my bed on an SE, but it's not the center of your bed for a Macs. You'll need to recognize, say here, I'm defining the bed mesh, the corners of the mesh, and the Macs corners of the mesh are not where you're going to want them. So Macs people have a special task to perform here that the rest of us thankfully do not. You'll need to go through here and recognize what you have to change to make it work with the dimensions of your system. I think the more subtle ones here, and again, it's hard to just search, but the more subtle ones are going to be in end print, for instance. In end print, you have a command here to present the print at the end of the job. And of course, 225 is not going to be the rear coordinate for your printers. So you'll need to go through CR6 and find them. You need to go through DGUS-Reloaded because there are things like Xmax, Ymax specified in here, which won't be the correct values again for your machine. And in printer config, the main file, you have the stepper definitions, including maximum position to which the steppers can go. So you'll need to take your trained eye through all of these settings, thinking is that right for my Macs? So there appear at first glance to be an enormous number of files to understand. But truly, the way this is organized, some of these you can ignore until you're ready to focus. So until you want to know what sonar is or time-lapse is or how to get a camera on, you can ignore those things. Until the day you want to do development, you can ignore all the development macro stuff here. Where you really need to focus your attention is on CR6, which is where most of the macros are. DGUS-Reloaded, which contains a lot of the stuff that is specific and special to DGUS-Reloaded. And Printer.config, which is the big one that Clippy focuses on. Klipper assumes Printer.config contains everything it needs to know, and you, by using include statements, give it other information that you chose to keep separate from the Printer.config file for information management purposes. In truth, everything that's in CR6, DGUS-Reloaded, and Input Shaper could in fact have been folded into Printer.config. I kept them separate for convenience. Like Input Shaper config contains the information for how to activate your ADXL345 and tell it what to do. And you can disable that by simply commenting out the include statement in Printer.config rather than having to delete everything, put it somewhere safe, and bring it back later. So anyway, you are going to need to focus mostly, I believe, on tailoring if you don't have a Macs, on tailoring the macros in CR6 config to your liking, and on tailoring the Printer.config file to anything else that you wish to change. So on Printer.config, really, I gave you a write-up at the front. Tailor this file and calibrate your printer before trying to print anything. And I did my best to tell you what that meant, where to go and what to do. If I stand here and read it to you, I'm just burning up your time. It's all in there, I hope. What I may have not consistently done, you guys flag me and let me know, is I may have put other information deeper in here that I didn't repeat up there. So take time, carefully scan through everything where there's a note, like include input shaper config is probably a bad idea for you until you've done input shaper calibration, so you could comment that out. And if you do disable, comment out the input shaper include, then come down here to kinematics under the printer and change your max XL to 500, which is the default for Marlin and the community firmware. And max XL to decel should be half normally of what the max XL will be. And since you're only going to allow yourself 500, change the 6 to 5. Okay, so all of that needs to change as well if you're truly going to wait until you have calibrated your own machine for input shaping before you try to use these values. Okay, so you may want to comment out is what it says right there. Yeah. So read very carefully, think about what's happening, and if you're not clear on something, clicking on configuration reference will take you to Klipper's own documentation. Will clarify what all of these things are and why they're required, which ones are mandatory, which ones are optional, what the values are doing to you, and so on. So that's all there as an encyclopedic reference. So stock printers are all delivered with 1.8 degree motors. That means every step, full step, is 1.8 degrees turn, so 200 steps takes you 360. With Marlin, we used to measure steps per millimeter and input that into the configuration file. Now, with Klipper, they do this a little differently. They calculate rotation distance, so how many millimeters has something traveled in a full rotation. And the formula is given in the Klipper documentation. Something called rotation distance is one of the chapters you can choose from the table of contents here. And if you look through it, it'll explain what it's talking about, how to get from steps per millimeter to rotation distance. Right? Step distance is an older version of Klipper. So here's the formula. rotation distance equals. And here on the internet, you can find everything on the internet. There's a calculator that makes this all so very easy. So thank you to 3D Print Beginner. You scroll down here to his calculator. With a stock machine, you're talking about a 1.8 degree stepper. You're talking about 16 microsteps, the same thing defaulted in the community firmware. And you see it in the printer config. Recommended start value was around 93. That would give you 34.408. Klipper says round to the nearest whole number, so you're in that ballpark there of 34 something. If it turns out your steps are more like 96, then you're talking 33 something. So you see how that varies. In my case, when I'm talking the orbiter, the start value they recommend in the market is 690. So that would give me 4.63. And yet I'm using 35 something. And it took a friend to remind me that the difference between you and me is I have a gear ratio. So if you're using a multi-gear extruder, and you do in fact have a gear ratio to enter, for instance 7.5 to 1 on the orbiter, you do have to multiply the number that calculator gives you by the gear factor, so that if I take my value of 4.63 and I multiply that by the 7.5, I come back around 35. But that's how you use the formula and the calculator to get from steps per millimeter, which you already know, maybe, if you're using Marlin, to what the rotation distance should be. On the stepper motors then, in the Marlin configuration, your steps per millimeter for X would be 80. In my case, it was 160 on Y, only because I have a 0.9 degree motor there. Yours would be 80 on both, and 400 for Z. So if we went back to the calculator, and we punched in, tell me what to do for 80, the answer is 40. And if I ask you what do I do for 400, the answer is 8. We come back here, and we see rotation distance of 8 on Z, 40 on X, and only because I'm using a 0.9 degree motor, I put 20 here. Now, there is a parameter you'll see for motors, steppers, that can be defined and is not defined here. So Klipper will use a default value of 200 steps for full rotation if you don't specify the value. And that's why if I put 20 here instead of 40, it acts as though this is a 0.8 degree motor. You have the option, if you wish, if you find that this makes it more intuitive for you, because 1.8 degrees times 200 is 360 degrees, and most of us know that's a full rotation. So I can actually, per the rotation documentation, define a parameter called full steps per rotation in printer config. So I could come here and type full steps per rotation as another parameter to specify. Klipper will default to 200 if you don't give it a number. But if I say 400 here, and I leave this as 20, I'm in trouble. I have to put this back to 40. So the rotation distance per full rotation of 400 steps in my case is still 40, because this is determined by the gear, right? There's a gear strap pinned to the shaft of the motor that has X number of teeth on it. And when it rotates one full rotation and it pulls a belt with a certain spacing on the cogs of the belt, that's always equal to 40 millimeters. Doesn't matter whether it took me 200 steps or 400 steps to achieve one full rotation distance is still the same number. When I change it to 20 in that setup, I'm lying to Klipper about the 400 steps part. But if you want this to be more clear, what you might want to do is go ahead and paste full steps per rotation in on the motors and change that to 200 for a 1.8 degree motor, and that'll work just as well. Klipper will know exactly what you mean, and you might find it easier to interpret things. All that being said, in the event that you don't want to do that and you just want to make sure that your 1.8 degree motor is correctly configured in this file, change the 20 to a 40. If you want to put that in instead and you leave that as 40, because that 40 is the correct answer really from the physics and the inspection of the device, you can change this to 200 because that's what a 1.8 degree motor is, and if you ever upgrade to 0.9 like I did, you change that to a 400. My printer is a direct drive configuration with an Orbiter 1.5 extruder. So if you're working with a stock Bowden system, I recommend you change the max extrude only distance here from 200 to 1000. Be more compatible with your setup, and then you can tune that to your liking. And you'll want to change the extruder settings here, so you want to uncomment the rotation distance there. Take away the blank space so it's up against the margin, and you want to comment out the orbiter like that. I'm presently using a 0.6 millimeter nozzle. You'll find the file says 0.4. So if you're using a 0.4 millimeter nozzle, you're good to go. If you, like I am using a 0.6, edit that value there to 0.6. And on your thermistor, I have a PT1000 thermistor installed. You probably do not, so if you do not, comment that out. Uncomment the sensor type here. The one NTC100K is most likely what you have installed. If your hot end is not capable of more than 260 Celsius because it has a PTFE tube in it, you'll need to change this setting for a max temp setting back to 260 from the 320 that I have set it to, because I'm using a Dragon high flow hot end as it happens, but any hot end that's all metal should be capable. You have to check the ratings. It should be advertised capable of 320C. And if so, then you can change the max value here to 320C. But if you're working with a stock extruder or anything else that has a PTFE tube in the center, you're limited to 260 for safety. Above that, your PTFE tube might start off-gassing toxic VOCs. And the rest of this, you're going to do a PID, right? You're going to go to the DGUS-Reloaded display. You're going to go Calibrate, PID, Nozzle, and run the PID at the temperature that you prefer to work, and do the same thing again while we're here. Let's talk about it and do the same thing again for your heater bed. Run a PID and save config, and the system will comment out these settings by itself, and it will install the new settings underneath the header and maintain them for you there. Although the DGUS-Reloaded interface does have an ABL function, when it comes to configuring your bed mesh and calibrating your machine the first time around, use the macros. The limitation on the DGUS-Reloaded is that it is only able to update the mesh called default. But in my start print macro, when it comes to bed mesh, I am clearing whatever mesh is presently loaded because I don't know what you've been doing. And then I'm going through this if statement. So if the bed temperature is greater than 70 degrees Celsius in the slicer G-code file, I'm assuming you're printing something from 70 to 80, 90 degrees, and I'm calling that PET G because that's what I work with. And I've got a profile saved when I run that 80 degree macro. If I'm printing PLA, I typically print at 60 degrees C. You may print at 55, some as cold as 50. I've said if the temperature is greater than 50 but less than the 70, I must be printing PLA. So I have a bed mesh that the macro will store with the profile name bed mesh PLA. And default is what I use if I do an ABL with a cold bed, no heater at all. Sometimes people print TPU, let's say, to a cold bed. So you need to store all three profiles, and I'll show you with the height map function on Mainsail the differences in my printer between the three profiles. I find it makes a big difference to my adhesion and my first layer quality if I use the profile closest to the temperature at which I'm printing. So this is something you couldn't do with Marlin that is dirt simple with Klipper, and I'm taking full advantage. So to run the macros, you come to the dashboard, go to the macros window. All the macros you've defined are listed in alphabetical order. You're looking for run, ABL cold. That's the first one you should run. Then 60, and then 80. Cold will run right away. It'll store to the default profile. 60 will take the bed to 60 and then soak it for 5 minutes and then probe your bed and save in the bed mesh PLA profile. 80 will take the bed to 80, wait 5 minutes while it heat soaks, and then probe the bed and store to the bed mesh PETG profile. When you've completed all that, you now can go to the height map function. In fact, you could go after any one of them to have a look. You'll see the profiles you have saved so far. You'll see the range of values that they've had. So see, minimum to maximum is displayable here just with rolling your cursor over the range values. You decide if a possible spread of one full layer height is good enough, or if you want to keep trying. You know, you engage in all that chicanery with silicon spacers and tightening things and running them again. People can spend days gleefully trying to perfect that. But quite honestly, your ABL can do that just fine as long as it is accurate. And it's not a big difference in total value between the PETG and default. You might be tempted to just go ahead and print. But if I look at the shape, it concerns me. And fair enough, maybe this is exaggerated on this scale. But here I am looking at the front corner of the bed. See how low that looks? People often find that they're scraping the bed when they come to print the front corner because it's artificially low here. That's a question of eccentricity and so on. But you see the shape difference from front to back at PETG temperature versus the default value. Very different looking shape, yeah? Not as depressed at the front, quite high at the back, because it's all relative to the center, and the center is not as pronounced. It hasn't domed up as much when it's cold as it has when it's hot. So there you go. There's my rationale for the 3 different profiles and the mechanism in Printer.cfg for how it's used when printing. And now we are almost ready to print. The last thing we need to do is to calibrate our Z offset. Now you can go at this a couple of ways. In the Klipper configuration documentation, there is a reference on how to calibrate the probe called bed level probe calibration, and the command is called probe calibrate. So you can go to the printer so that you can see what you're doing, go to the console and issue a probe calibrate command. It will take the tool head to the center of the bed. You see the tearing here and the probing. It's homing right now. And then it's going to pre-position the head at the distance it thinks is above the center point at this height. And when you're interacting with the printer, and right now I'm upstairs and the machine is downstairs, but when you're interacting with the printer, what you can do now is you can see by how much in millimeters you're going to raise or lower the head by tapping on a value. But here it's very clear to see I'm taking myself down by 1 millimeter if I select that, right? So I just do that a couple of times to get my head within reach of the bed. And when I'm there, then I start using smaller increments until I can see no light between the nozzle tip and the bed surface, or I can see in a reflection, depending, if I'm using a glass bed or a wham-bam bed, maybe I can see a reflection of the nozzle and I see the nozzle kiss its reflection. Whatever technique you want to use, most people will shout back, paper method. So yes, you can use a piece of paper, lower this thing until it's scraping the paper, but now your nozzle is not at the bed, it's thickness of the paper above the bed. So you really should make a measurement of the paper thickness and subtract that from the final value you got. But that's how you use Mainsail and Klipper to calibrate your Z offset. With the DGUS-Reloaded application, you have another choice. With a flashlight behind the nozzle, you can just see a flash of light, a strip of light between the nozzle and the bed. And if you go to the Z Offset screen and you select, say, 0.01 millimeters per step, as you step it down, you gradually see the light disappear. Until now, you're basically where you want to be. The nozzle is touching the bed. Light cannot get through. That is an offset to the offset. So that is a correction factor that you can now apply to the Z Offset to make it precise for your printer. So in my case, the offset has resolved at 0.06 millimeters, which means the 0.20 default is off, and sure enough I'm back to the 0.14 that I said was optimal for my system. So to save that now and correct the offset, you press Save Config, and that will save to the printer and reset. And now my offset is the 0.14 instead of the 0.20. And I don't want to leave my bed with the nozzle pressed up against it in the center, so I want to remember to home all when I'm done. Now we're already much longer video than I was hoping. I'm going to cut it here. I'll come back and make a fifth step. But I want to talk about integrating the slicer because we've ignored those files in the Klipper component that we downloaded. I skipped right past that folder, and there is more to know. So let's call it a day, and I will be back soon, very soon, as I'm working on it now, with the final video in this series that says, okay, now we've got it all installed on our machines. We have the printer calibrated and ready to print. I'd like to integrate my slicer to make printing that much more convenient. See it. I will talk to you soon. Bye-bye.